I just finished my class and I'm going to send you the email address, and I will send you the email address. Okay, so this sentence may seem pretty weird, but if you look at little parts of it, they certainly seem like things you might say. This is an example of a predictive keyboard. It predicts what you're going to write based on lots of different factors. So how do predictive keyboards like this work, and how are they so good? To find out, let's make a program. But first, I want to see how good a human is. This is my sister Clarabelle. I'm going to be reading her a text, and she's trying to guess which word comes next. Alright, first word.
Hi.
Nope, starts with W.
Where?
Nope, W-E.
It starts with W-E. Welcome.
Nope, W-E apostrophe.
We're.
Yep. Next letter, or next word.
We're going.
Nope, starts with O.
We're on.
Yep.
Our.
Yep.
Way.
Yep.
There.
Nope, starts with H.
Home.
Very good, we are on our way home. Alright, now we know what our program should be able to do. But how do we make it actually do that? Well, let's start out simply. We'll make a really simple program and see how well that works. Well, we can just take a dictionary and pick 3 random words from that. I've got a dictionary. Picking 3 random words gives hickory, pre-embryo, and suffocate. Not super helpful. How can we make this program better? Well, predictive keyboards can use letters that are already typed, right? If you start typing part of a word, it can change what's suggested based on that. So we can look at that in our program and only suggest words that fit what's already been typed. Let's say we've already typed the letters TH. Then this program would suggest 13th, thecate, and thesonical. Not really helpful. The problem with our program so far is that it's only suggesting really uncommon words. What if we took only common words and suggested those? To do this, we can use the Corpus of Contemporary American English, or COCA. It's a collection of a whole bunch of American English that's been compiled together, and we can just use it to find out which words are the most common. Now that we're only choosing the most common words, our program, given that nothing has been typed already, is going to suggest the, be, and, which is really helpful. Those are words you're going to use a lot. And say you've typed th already, it's going to suggest the, that, and they. Also really helpful. What else could we add to our program to make it even better? Let's say I've just typed the word the, and I want to see what comes next. Our program is going to suggest the, be, and again, because those are the most common words. But I probably wouldn't be using those words after the, right? I wouldn't write the, be, or the, and. So we need something else in our program. We need to look at the context of the words around it. If we look at which word came right before it, and then give that to COCA and ask which word is most likely to come next, this is going to improve our program a lot, because instead of writing the, it's going to suggest the person, which is much more likely for someone to write. Alright, our program is working pretty well so far, but there's one more thing we could add. What's common for me to write is probably not what's common for you to write. Different people use different words, write different things. This is why when I type "hello, my name is," it comes up with Seamus. So if we look at the user's history, that tells us which words are common for that user. If we look at COCA, that tells us which words are common for English in general. By looking at both of these, what's common for the user and what's common in general, and at what word was just typed and which letters have been typed already, we can come up with 3 suggestions that are really likely to be written. Alright, so now our program is working pretty well, but we're looking at all of these factors, we're doing all of this work. Clarabelle is doing all of this subconsciously, she doesn't even have to think about it. Isn't that cool? I mean, this is why we can make typos or stutter, and people still understand what we're saying. It's because people can put themselves in the shoes of another person and think about what they are trying to say. It's pretty cool that humans are that good at it. It's pretty amazing that computers are as good as they are.